This lesson is on the law of cosines, and our objective is to be able to use that to solve triangle sides and angles in a triangle. We've used the law of sines already, which, if you recall, is the sine of an angle over its opposite side. So sine of A over A, sine of B over B, sine of C over C. We set up a proportion with two of those ratios and solve for something missing. Now in our triangle, that could be given two angles and a side, or it could be in a triangle if we're given an angle and two of the sides that are not around it. So that would be side angle. That will be a case that we'll talk about later as a special case of the law of sines. But we need a tool. What if we're in a different situation? I mean, what if we're given all three sides of the triangle, A, B, and C, so all three of the sides? How do we do that? Because in the ratios, not one of the ratios is complete. Or what if instead of that, we're given two of the sides, like for instance, given side A and side B, and the included angle C. That's the one that's right between them. We don't have a complete ratio to set up to do the law of sines, so we need a new tool. And that new tool is going to be called the law of cosines. It's based on using the cosine because it's got side, angle, side covered with that included angle, or side covered where we can solve for the missing pieces of the triangle. So as we set up the law of cosines, we're going to start with, let's start with A. So if we have A as the side we're going to use, we're going to set up A squared on one side of the equation, and what you should notice in this equation, it's going to be equal to B squared plus C squared, the two other sides squared, minus 2 times B times C, the other two sides, times the cosine of that angle A that's opposite that side A. So anytime you have a side, you need the angle opposite it on opposite sides of the equation to set up. Now, that would work for any of the pairs of angles and sides. If you want to do it with B, just remember, if you have B squared by itself, then you need to have cosine of B on the opposite side. If you want to do it with C squared, then you want to use cosine of C in your formula. But this will help us solve for missing pieces in these different cases that the law of sines doesn't work. Now it's important to recognize that when you use the law of cosines, it's best that you work with the longest side first, because that's opposite the biggest angle, and that helps us just in case we have an obtuse angle. The law of cosines can handle an obtuse angle. The law of sines, you have more difficulties with that. So that's why you want to make sure you take care of the longest side on the left side of the equation first. So these are the three ways we solve triangles. The first way is right triangle trig when we're given a right angle. That's the type of situation where you use what we know with right triangle trig. Law of sines, on the other hand, is when we're given two angles, like angle, side, which is the non-included side, or angle, with the side included between two angles, or side, angle with the angle not included between two sides. That would be law of sines. We're going to talk about the law of cosines today, and that's side, all three sides given, or side, angle, side given to you, the angle between the two sides. When you use the law of cosines, it's important to recognize that after you use it, it's best then to go on and use the law of sines after you use the law of cosines. It's usually easier that way, and by the time we solve for one of the other pieces of the triangle, we have enough information then to use the law of sines to get the other sides and angles in the triangle. In this sample problem, notice we are given two sides and the included angle. So in this case, as I draw my triangle, angle A is given to us, so that's going to be 50 degrees. And then we're given side B opposite angle B, which is 15. And then we're also given side C, which is opposite angle C, which is 30. Now, when we set this up, we're going to solve for the unknowns. We don't know side A, we don't know angle B, and we don't know angle C. Those are the ones that we're going to find in this triangle. So that's our next step. Looking at this though, we're going to use the law of cosines with the A side and the cosine of A in it, because that's what's given to us with the angle. So A squared equals that 15 squared plus the 30 squared minus 2 times those sides given, 15 times 30, times the cosine of that angle that's given to us, which is 50 degrees. Now that we can do on our calculator. So A squared is going to equal this calculated out. So use your calculator to come up with that number, which in this case is 546.49, etc. It's a long decimal. Then we just take the square root of both sides. We get our answer to be approximately 23.4 when we do it to one decimal place. So what we want to do is we want to make sure we put that in our answer blank, 23.4. And now we're going to switch from the law of cosines to do the law of sines. So in the law of sines, we're going to focus on using the shorter side on doing this. That only helps us just in case there is an obtuse angle. Law of sines doesn't handle that obtuse angle very well. So there can only be one obtuse angle. So we'll start with the shorter side because that will be the smaller of the two angles, and that will help us solve this problem. So let's do the law of sines with what we have now. That's sine of 50 degrees, the angle given to us. We calculated A is 23.4, so there's our first ratio. That equals, now let's find B. So we're going to do sine of B over the side B that we have, which is 15. Now we solve this proportion. Now let's do a problem where we're given all three sides. Now we get to pick which angle it is that we're going to figure out. So let's draw a diagram for this. Drawing the diagram, again, we just draw a triangle, and then with that we put in our angles, and the sides are going to be opposite those. So angle A, angle B, and angle C. So when we put in 8 in this case, that's side B, so it's opposite B. 6 is A, so it goes opposite angle A, and 12 is in for C, because it's opposite angle C. Now, what we don't know is any of the angles, so we need to calculate angle C, angle A, and angle B. Now, I'm going to start with C, because it's the longest side. Remember, if there's going to be an obtuse angle, it's going to be with the longest side, because of the opposite side is the longest. Therefore, we'll start with angle C and the formula of cosine C in it. So C squared is on the side opposite, so 12 squared equals 6 squared, A squared plus B squared, plus 8 squared minus 2 times 6 times 8 times the cosine of that C. Now, we're going to do our calculations. 12 squared is 144. 6 squared is equal to 36. Our 8 squared is equal to 64. Our 2 times 6 times 8 is 96 times cosine of C. Now, here's where a warning. I want you to be careful at this point. You might do the wrong calculation if you do that minus 96 from the 36 and 64. Be careful, you can't do that because order of operations says that 96 is times the cosine C. It stays with it. So we're going to subtract 36 and 64 from the other side. Leave order of operations where it's negative 96 times cosine of C. So keep those two together. Now we'll calculate 144 minus 36 minus 64 gives us 44. Divide by the negative 96 to get it on the other side. That equals our cosine of C. Now we can take the inverse cosine of both sides, the cosine with the little negative 1 of that fraction. We'll put it in parentheses, so 44 over negative 96, and the parentheses. and then we calculate that on our calculator, and we get an angle measure out there. And notice it is an obtuse angle, 117.27, etc. We're going to round that to 1 decimal place, so it's 117.3 for our angle C. Now, once we've got one of them, let's use the law of sines to calculate what comes next. So I'm going to do the smaller of the two, which is A, so sine of A over 6, the smaller side, equals sine of 117.3, that's angle C, over side C, which is given to us as 12. Now we can multiply by 6 on both sides to get it out of the denominator. Once we do that, sine A is going to equal that 6 times sine of 117.3 over 12. We can now do that calculation on our calculator to get what sine of A equals. So it's going to be about a decimal of about 0.4443, etc. And it keeps going. Now we go ahead and figure out what that angle is by taking the inverse sine of that decimal, because that's the simplified decimal of the work we had. Once we do that, we get angle A. And so our angle A is about 26.37, etc. for a decimal. Rounded to 1 decimal place is 26.4 degrees. Now all we have to do for that last angle of angle B is take 180 minus the angles we have, 117.3, minus also the 26.4, and then we'll get angle B, our last angle, so we've solved the whole triangle, of about 36.3 degrees. So solving the triangle using the law of cosines is when you have 3 sides or 2 sides in the included angle, and you use that to find the missing pieces of your triangle.